The first step in solving the higher order differential equations is in writing a certain equation into a form where we involve a certain differential operator commonly denoted as a capital letter D. This is what happens usually in this process if you have dy over dx. This can be rewritten in such a way that when you let d over dx as equal to the capital letter D, this is just equal to d and then y, because this is just d, you still have the operator of y here. Okay, so please take note of that because that's part of our analysis later. As well as, it's also important to know what is our dependent and independent variable here, because looking into this is of course your dependent variable rather, okay, and this is your independent variable. Because what will happen now is that you will be looking into the dependent variable as part of your equation now. So generally, in the first equation, your dependent variable is of course y, but your independent variable is not specified. Okay, not specified. Same as true with our second equation, independent variable is y. The independent variable is not specified. Commonly, we use x there, but since it's not specified, let's not use any in the meantime. For our third equation here, your dependent variable is what can be found here. So it's not all of the time y. In this case, it's just x. But your independent variable now is this here, that's t. And for our last equation, our dependent variable is r, and our independent variable is also t. Okay? So we need to look into this because we will be using this dependent variables in the given process. Let me erase this and let's start writing them now. The notation for an equation using differential operator is in this form. You will have f of dy, where your y, okay, where your y are equated to 0, where your y here is your given dependent variable. But it's not all the time y, because just like in the third equation, it's x, in the fourth, it's r, so you also need to change it. So what happens here is this. For your first equation, the y, the second order derivative of y minus first order derivative of y minus 2y equal to 0, we can rewrite it in this manner. You use a simple substitute d for our order of derivative, but since it's second order, so we have d squared, then you have minus d, and then you will have here minus 2. And since they're all under this expression here, f of d, so simply multiply this with y and equate it to 0. This is now your equation in differential operator. And our second equation here, same process will come in. So if f of dy equal to 0, so you will have your d, the third order derivative, that's 3 here, plus 2d squared, plus 5d minus 26, and they're all multiplied with your dependent variable y in equating them to 0. This is the answer for the second equation. For our third equation, take note that our dependent variable is x. But don't forget that, of course, there is still second order derivative. So you will have f of dx here equal to 0. So you will have d squared minus 16. And then you multiply it with your x equate to the 0. This is your equation using a differential operator. And finally, for our fourth, take note it's a third order derivative and the dependent variable is r. So you will have your f of dr equal to 0. So you will have the third order derivative of r with respect to t minus the 5 times the second order derivative plus 25 first order derivative minus 125. All of them has r, because this is, again, as mentioned earlier, this is what we substitute for our d. So we still have r for each equal to 0. Please take note of these answers because these are also very important, as this is the first step in solving higher order differential equations. And on our next video, we'll be using all of this to come up with another equation we call auxiliary equation. Thank you very much for watching.